So why don't I make a start? My name is Alistair Parkinson, and I am the CTO of SOA Software. And we were talking a little bit about APIs and APIs as they relate to the data center specifically. Advance my slides here. So obviously SOA Software is in the API management business, and we have been in this business for a while. And what we work with is typically large Fortune 500 customers. And what we see from our customer base is typically two core API use cases. And the first use case, or the first set of use cases, is probably around internal APIs. And one of these internal APIs is the Datacenter API, and that's the focus of today's presentation. I'm going to be talking quite a bit about that and how it all fits together. But we also see some other use cases that I think are worthwhile noting because they set the context and they also help illustrate the point. So when you look internally and the internal use of APIs, we certainly see the Datacenter API, but we also see a platform API. And what the platform API is customers that are building out an internal architecture around potentially an automated cloud-based environment, and they are putting together a set of shared APIs or shared services that compose ultimately a platform API. And the way that this is kind of taking form within organizations is they come up with a standard cookie-cutter way of deploying applications. And then they also come up with a way of publishing a set of horizontal and vertical APIs that are shared amongst all of the app developers. And the app developers will basically go in, provision an instance of the platform, and build apps on top of that platform, and through that either expose or consume APIs. And the way that I like to look at that is almost as a reinvention of a service-oriented architecture. It's leveraging, or it's doing, service-oriented architecture with APIs. And this to some people might be a strange concept, and to others it might be natural. But basically, if you think about service orientation, it's not a technology choice. It's more of a mindset about how do you actually reuse, how do you actually build applications internally, and how do you integrate those applications within your environment. So if I look at the Datacenter API and I look at the Platform API, I see them as instances of organizations trying to do a service-oriented architecture and focusing on either the operations and infrastructure or the application development lifecycle when they are doing so. So we see a lot of internal API use cases around either SOA related or around a Platform API or a Datacenter API initiative. If you think about the demand that mobile applications and web-based applications are placing on back-end apps, and the fact that all of these things are presented as or integrated using APIs, you can see that API has become the new way to do application-to-application integration. Mobile applications are consuming back-end APIs over HTTP using JSON and a REST style of invocation. And web-based applications are turning that communication mechanism as well from a traditional server-side MVC model to a client-side MVC model that is really reliant on and depends on a REST JSON style of API. In the future, we're going to see lots of other things come out, right? So you're looking at WebSockets, we're looking at Thrift, we're seeing other ways that people are technically implementing APIs, but they're still just APIs. It's a different technology choice that customers have to embrace, and it's all about whether or not they package it up as an API or as a service and present it almost as a product within the organization, and to try and create an arm's length between people who are building applications and people who are providing APIs. So when we talk to our customers, we see a lot of internal API use. And then we also see a lot of external API use. We see typically two different kinds. The first one being B2B APIs. So organizations are using APIs to attract partners, to build up a channel, to integrate with their partners' systems, to create different kinds of syndication mechanisms, or to create mobile app integration mechanisms. And all of these things are changing the landscape of B2B and B2B integration. It's gone from EDI to XML to JSON, and it's going to go forward into new technology sets. So we see a lot of customers exposing APIs simply because their partners are using mobile and web channels that fundamentally need and are fundamentally architected around APIs, JSON REST style APIs. And also the technology sets that the partners are using are more API native. They're better at using REST and JSON than they are potentially at using XML and SOAP. So we see a lot of B2B API use, and this probably drives the majority of what we do as a business, because we're largely focused on enterprise, we're largely focused on IT, we're largely focused on an extension or a reinvention of SOA. The other bucket of bits is the public API. And this is organizations that are exposing the API as a first order, as a digital channel alongside or along with their website, and are putting it out into the public and trying to generate demand and generate a new channel for their business. So this is akin to the Facebook, the Netflix, and all of these people who are putting out public APIs into the Wild West, essentially, and promoting them and marketing them as a channel to the public, to the consumer, to the end user, to an app developer sitting in his garage, or potentially to other B2B partners. So it's kind of an extension or an opening up, I guess, of what might start as a B2B initiative and then ultimately become a public initiative. We're also seeing organizations go backwards and first launch a public API because it's sexy and cool, and then focus on how do they really make money and end up having a B2B API. And we've seen that play itself over in the marketplace. So this is at least our impression of the market. We're seeing internal APIs and we're seeing external APIs. And when we look at internal APIs, we're seeing how people are reinventing SOA with APIs, and how they're reinventing their data center and cloud, and how they're reinventing their internal app development platforms with API. So we're going to have a couple of other presentations that also tackle these other things, and you can come and see us at conferences as well, and listen to me talk about these things. But for this presentation, I'm going to focus primarily on the Data Center API. So without further ado, let's talk about the Data Center API. The goal of the Data Center API is to optimize utilization, gain competitive advantage, ensure flexibility, and manage risk. So I'm going to talk about all of these things in detail, but let's just talk about it generally first. So the idea here is that an organization is building out a lot of cloud, a lot of software-defined networking, a lot of storage, a lot of security and other utility APIs. And they want to actually create these APIs and expose these APIs internally to allow people to build new controllers and new next-generation applications on top of that API. Applications and systems that are fundamentally aware of and can control their infrastructure. Even if you don't do this consciously, every single vendor that you're interacting with, whether it be companies like Service Mesh or OpenStack or vSphere or Amazon or Floodlight with their northbound APIs, or storage APIs provided by vSphere or Amazon or Drupal, security and utility APIs, all of these systems, if you haven't sort of wrapped your head around it yet, all of them expose APIs. So if you take those APIs and you publish them and you abstract them from your organization, you can effectively put together what is fundamentally a data center API, a programmable interface for your data center that controls cloud, network, storage, security, and other applications that sit within your data center. And then on top of that data center API, you can build cool new things. You can build new things that control or optimize your data center or network. You can build applications that are cloud aware, cloud native, that can actually control the environment into which they deploy it and shave milliseconds off, or whatever the case might be, They can scale themselves up and down. They can control and affect their environment into which they're deployed. So the Datacenter API is a way that people can expose these different platforms and essentially allow them to optimize the utilization of their cloud infrastructure, which is probably the number one goal of cloud in general. It also allows them to gain competitive advantage by building cool new next generation applications. It gives them the flexibility to actually abstract or divorce themselves or isolate themselves from different cloud vendors and different SDN vendors and different storage vendors, and through that ultimately lower their risk. So if they can go from the top down and build a data center API that's namespaced or is specific to their organization, then they can mediate between that data center API and whatever the ultimate provider is of that API. It gives them the ability to arbitrage and to control who and what they're using. So hopefully I haven't completely taken the wind out of my next 3 slides, but let's go through these things in detail. So the first one is around optimizing utilization. So the idea here is that you can control and manage all the APIs exposed by your data center vendors. And this covers virtualization, storage, network security, and other applications that you have in-house. I guarantee that a lot of these vendors that you're using today, I mean, all the cloud vendors that I can think of, the SDN vendors, etc., they expose APIs. They expose REST APIs. They're all funky, and there's a lot of white space in there, and there's holes, and there's problems, and there's vendor lock-in, and all of these kinds of things. But at the end of the day, all of these guys are exposing APIs that you could actually leverage yourself. So the idea here is that you create this data center API platform designed from the top down. So put it in your namespace as an organization, or pick up something that's at least an open standard. So you can go and you can put OpenStack or something on top of other cloud vendors. And the idea here is that you can productize your data center API internally. So you build the API and you market, provision, support, and analyze what and who is using that API and what are they using it for, and ultimately promote and develop new command and control apps to optimize your data center utilization. So the idea here is that as an IT organization, as an infrastructure organization within IT potentially, you build a data center API, and then you productize that, and you then market that to the rest of the organization. So you create kind of an arm's length relationship between the infrastructure and the APIs that control the infrastructure and the apps that are leveraging those APIs. And you create a marketplace where people can collaborate around the development of apps and control and command applications on top of that API. And that's going to give you the ability then to leverage interesting ways to utilize your data center capacity or your network capacity, and hopefully report on and provide visibility into what and how you're using it. So let's look at the next set of things around competitive advantage. So let's assume that you've gone and you've created this data center API and you've marketed it within your organization. Now what you need to do is you need to create a social developer portal, an API storefront, so to speak. And you need to provide your developers with dynamic documentation. You need to manage the workflow around provisioning. You need to provide potentially OAuth as a security infrastructure to allow people to build the next generation of cloud-native applications that are aware of and can control their environment. So what this does is it basically allows you to build cool new apps that leverage and optimize the way that they use the data center. You can then provide policies and controls. I mean, the basic problem is that if you give these people power, they are going to, or if you give them an inch, they're going to take a mile, right? So you're going to have a whole bunch of badly behaved applications that consume your entire data center before you even know it. I can just imagine somebody writing in some kind of algorithm there that automatically scales their application, and they leave off a decimal point, and all of a sudden, you have 1,000 instances of this thing running in your data center. So you need to be able to control and provide policies and controls around that API. So you need to be able to both support innovation and agility and at the same time reduce your risk. Give them consistent and integrated API security, give them licenses, give them quotas, and provide protection for this data center API. I mean, imagine if somebody could get in and hack your data center API. you would be out on a limb. So you really need to protect and secure that API and make sure that it is safe and can be shared, and that you protect yourself from badly written applications or, heaven forbid, malicious applications that leverage that API. The third point is all around ensuring flexibility, and along with this comes, mitigating risk. So when I talk about the Datacenter API, I always talk about the fact that this really needs to be designed from the top down. So you need to think about what you as an organization really want to expose as a Datacenter API. You don't necessarily want to expose, the northbound APIs from an SDN vendor directly with their namespace, their nomenclature, their semantics. What you want to do is you want to figure out as an organization what you want as a Datacenter API and put that in your namespace with your definitions, and you want to control that. So design that from the top down, and then orchestrate the API calls across the back end. So abstract yourself or provide a layer of logic to simplify the complex control tasks. I mean, if you look at just the sheer amount of white space that exists in the SDN space and the storage space and the virtualization space, there's gaps there that you might have to fill with orchestrations or with control applications that you build yourself to create this Datacenter API. And then you're going to need to mediate the complexity associated with all these different backend mechanisms, API technologies, API representations, and mediate that to this, what's hopefully a nice, consumable, easy-to-use, marketable Datacenter API that's used internally. And then this Datacenter API must actually allow you to build cloud-native applications that are abstracted from specific vendor implementations. So if you pick up a particular vendor for SDN or for cloud or for storage, you don't want to be tied to them. And if, as an application developer, you are actively using their API directly, you're going to run into trouble. You're going to be tied into a particular vendor. So you want to lower the risk by decoupling your business from your technology processes or your IT decisions on the back end. So let's look a little bit at the Datacenter API and kind of the high-level architecture of what this thing looks like. So the Datacenter API is an API that's listed and published and marketed in a developer portal of some kind. And I'll talk about what we offer later on in this space. But the API platform needs to offer a whole set of capabilities, from security to metrics to licensing to OAuth to the toolkits to provisioning, lifecycle management, all of these kinds of capabilities. And it needs to provide you with the orchestration and mediation to all of these back-end APIs. And you can pick up different kinds of APIs for different purposes. So let's have a look at these. So when you look at cloud infrastructure, you're abstracting, your Datacenter API is basically providing a single API across different cloud providers. It abstracts your app developers from any specific vendor implementations. And if you look at the vendors in this space, I mentioned Service Mesh already, but you have OpenStack, you have VMware, you have EC2, you have eCloud, you have Rackspace. They all might have either proprietary APIs or be standardizing on something like OpenStack. But the goal here is that you need to be able to take these APIs and abstract yourself from them. So your Datacenter API might not look anything like OpenStack. It might be very function-based. It might abstract a lot of the technicalities and the details around provisioning individual VMs. It might just be, say, hey, provision this app, and all the details of the wiring and the virtual machines and all of the low-level stuff is completely abstracted at the Datacenter API point. But the goal here is to build an API that provides you with that abstraction and isolates you and provides you with portability across different cloud vendors. You might have, or you might be wanting to leverage EC2 as well as something internal, as well as maybe another cloud vendor like Terramark or Rackspace, and then you might have VMware already internally. So you already have a bunch of APIs. Terramark has an API, Rackspace has an API, EC2 has one, VMware has one, and OpenStack has one. And everybody's fighting for space, and you need to protect yourself from that. Software-defined networking. I mean, basically, again, you want with a Datacenter API, you want to be able to leverage a single API across whatever comes out of the SDN space. The SDN space well, there's a lot of white space inside the SDN space. So what SDN provides, or what the Datacenter API should provide, is a way to abstract your developers from the underlying protocols, OpenFlow, BGP-LS, or etc., and opens up that networking layer. So you might be taking the Open Daylight Northbound API or the Floodlight API and using that or components of that solution, but you don't necessarily want to expose those APIs natively to the applications that are using that. You might also, if you look at all of these implementations, there's big holes in them. They don't necessarily do what you might necessarily want to do as an IT organization. So you might have to complement them. You might have to add to them. You might have to write some of your own stuff. So the idea here is, again, to provide you with abstraction from the SDN vendors, and that's a very maturing marketplace. There's a lot of stuff going on there. There's a lot of agility, or a lot of movement in the space, and you need to get a handle on that, figure out what the core use cases are that make sense for you, and how you really want to control maybe the routing across your network and provide that to the applications that are running inside the infrastructure. Storage and content. So the Datacenter API, again, allows you to abstract storage and encourages the development of cloud-native applications. Applications that use native storage are a problem. Applications should start using a storage API. And, this is kind of fundamental to the ability to actually move your applications, which is part of the definition of being cloud native. You're no longer aware intimately of the infrastructure that you're running on. So you need an API that's going to abstract multiple storage systems, whether they be file system, database, FTP, S3 from Amazon or CloudFront, Akamai as an SDN vendor, or other SDN vendors like Edgecast, or Rackspace Cloud Files. Everyone has a storage API, but you don't want to necessarily write applications that are closely tied or closely coupled to that storage API, because then you're never going to be able to move it. So the idea here is to create a storage API or a content API or both, and give you the ability to transport and move between the different systems. So what we do for our customers is we work with them to figure out what are the components of this data center solution. We take our API platform, we couple it with the Drupal storage API, for instance, or other storage APIs with the Floodlight or the other northbound APIs for SDN, a cloud vendor such as Service Mesh or others that provide these APIs, and we work with our customers to create what they want out of a data center API. And then we provide a set of capabilities on top of that API. Let me talk about those briefly. So, excuse me. Our API platform provides a set of fundamental capabilities. Starting from the bottom, it provides lifecycle management. And there are a lot of aspects around lifecycle management that are vital. App lifecycle, API lifecycle, provisioning lifecycle, development lifecycle. And I'll talk about these briefly. Then you need service integration. So you need to be able to speed up and simplify the development of this data center API. So you want to be able to integrate these things. You want to be able to do orchestration, mediation, transformation, those kinds of capability that fall into that service integration space. You also want to be able to secure and protect your systems. And this is provided by a set of gateway services. So quality of service, denial of service, script injection, SQL injection, all of those kinds of protection and security services, OAuth, HMAC, whatever they might be, are provided by a set of gateway services within the architecture. Then there's developer engagement. The whole thing about APIs and what I believe is core to the reinvention of SOA is the creation of the API as a product and the adoption of the API by the business or part of the business and the marketing and the promotion of that API. The reason that APIs are successful, I believe, is because they are productized and there is a supplier and consumer kind of concept around an API that's very explicit, and there's an arm's length relationship between that consumer and that provider of an API. Nobody goes to Facebook and says, hey, please change your API. It doesn't work the way I want it. Facebook goes out, they put some research in, they build the API, they launch it as a product, and people adopt it. And that is fundamentally different to what a lot of people implemented as a service-oriented architecture, which is more interface-based, application-to-application, collaborative, and funded by projects or lines of business. APIs are productized and have built within them this arm's length relationship. And that's really facilitated by a whole new crop of developers that have come out that are now used to programming against APIs, the Facebooks, etc., and are used to this relationship between them as a developer and the company as an API provider. And this translates both from the external-facing API to the internal-facing API as well. So if you're going to be putting together a data center API, I suggest you productize it, you market it, you make it pretty, you collaborate with the business on how to launch it and how to create a marketplace where people can consume it. So you want to basically build a developer and partner ecosystem around the API that you're creating. And then last but not least, you need to get some analytics. What is this thing doing? What are people using? How are people using it? And what does the next version need to look like? So let's look at the lifecycle management or program management around APIs. So when you look at lifecycle management, there is the lifecycle of the development of apps and APIs. So how do people build apps and how do people build APIs? And you need to be able to provide templates and best practices and controls around how people are building APIs and how people are building apps. And this is very pertinent when it comes to the data center API. You need to understand, or you need to control the versioning and the life cycle of the data center API, and you need to understand exactly what the impact of change is for any one of your backend centers. You're going to be building some glue in the middle to expose an API or to put something together, or you're going to be doing some orchestration. You need to understand what is the relationship between the data center API and all of its components and all of the vendors that are providing those components. You basically need a map that shows you the way. You also need to be able to disseminate the best practices and templates to the developers that are building APIs and building apps that are using your data center API. You need to control the approvals and the workflows around both the apps that are being built as well as the API, and as well as the API's production lifecycle as it moves from dev to staging to production. What is the workflow? What is the lifecycle around that? And these are fundamental lifecycle management problems that you need to solve as an organization. And if you use our Lifecycle Manager product, you get source code development integration, you get IDE integration. You literally get a map of what version of an API is using what version of what backend system, what policies are being invoked, what dependencies are there, what happens if something changes, and you can pivot it based on what dependency or what object you're interested in the most within your SDLC process. So that's lifecycle. And lifecycle has lots of different angles. Then there's service integration. And as I said, service integration is all about how do I speed up development? How do I create orchestrations, the process composition? How do I improve my time to market? How do I quickly get this data center API out through a drag and drop composition or orchestration process? And how can, for the things that engine can't do, how can I actually prototype, or how can I actually write scripts or customize or run custom code within the architecture? So what we've done is we've built up an API gateway that includes process composition as well as native scripting capabilities along with a drag and drop editor. So you can basically take a set of backend APIs by these different vendors, drop them into the system, transform them, execute scripts against them, orchestrate them, to basically provide and expose your data center API. Alongside that comes a set of gateway services. So how do you secure and protect your systems? How do you prevent attack? How do you provide caching and paging? How do you manage quality of service? So how can you actually enforce authentication and authorization at runtime? Maybe you want to provide OAuth alongside OpenID Connect. Maybe you need to integrate with existing federation and trust systems. Maybe it's SAML. Maybe you have backend SOAP APIs that are using WS security. Maybe you have a WS trust implementation. So all of these kinds of things play into it, and you're going to be exposing this data center API, hopefully with a nice clean security model on top of it, and you're going to have to sit there and mediate between different back-end security implementations across different cloud vendors and abstract the cloud vendor-specific credentials from your applications. So maybe you're using EC2. Well, hey, you don't want to expose the EC2 credentials to the application that's being built. You want to provide internal credentials and then map those to the Amazon credentials. So just simple things like that need to take place or need to be encapsulated inside the non-functional capabilities of your data center API architecture. And you're going to get things like, the drag and drop editor that exists in our API gateway, where you can invoke and execute scripts and branch and create sub-processes and all of those kinds of things. And you're going to get dashboards with flashing lights and pretty charts that tells you what's performing, what's not, and what the set of dependencies are at runtime. The next component is developer engagement. I spoke a little bit about this, but you want to build your developer and partner ecosystem. You want to create a self-service community potentially, where people can come in, maybe register themselves as a developer. It's integrated with single sign-on into whatever internal infrastructure you have. Interactive documentation. People can page through docs. They can play with the docs. They can send requests from the documentation. They can manage their app provisioning, so registration of an app, the issuing of API keys, the provisioning or the life cycle of the app as it moves from sandbox to production. Integrated testing, so how can they send test requests, see what the response is, build their app. Basically, simplify support for you as a data center API provider. You're going to be exposing this API. You don't want to be bugged all day, every day, with requests for docs, with requests for sample messages. It needs to be all there. Developers need to be able to get involved and participate in a community around the app development of apps around your data center API. Then last but not least, analytics. You need to measure the impact of your program. Who's adopting it? Have you improved the speed of development? Can you provide for visibility and performance and consumption? Give these developers the ability to debug their apps. What's going wrong with the particular developer's app? So they're going to phone you and say what's wrong. You need to provide the ability to give ad hoc analytics. So maybe you want to know how much storage is being used. So all of these kinds of analytics and charts and reports needs to be driven or driven up into the business through the analytics capabilities. So I've spoken quite a lot about the developer engagement. I think that, and I've mentioned all of these points before, I've talked about productization, and I've talked about moving the center of gravity. But another way to look at it is you want to move from a culture of integration to a culture of adoption. So you expose this data center API, and people adopt it. And it's very much step number one, expose the data center API. Step number two, have people adopt the API. And you can collaborate on it. I mean, it's a product. It's going to evolve over time. But one of the problems with service-oriented architecture, traditional service-oriented architecture, not one that we ever advocated, but the problem with that was that there was a proliferation of these interfaces because everybody built an interface for a specific need and for a specific purpose instead of thinking about what they think should look like as a product. So it proliferated. And I know that everyone had good intentions about what to do with SOA and how to build good services, but there were budgetary constraints. There was a problem with the marketing and the publishing and the provisioning of those services. We had some awful things like UDDI that really mucked everything up. It wasn't human readable. And APIs give us that opportunity to reinvent a service orientation and move from this culture of integration and move to a better culture of adoption. Move that center of gravity along. Let's see. I think I've covered that, and I've also covered this. So the other thing that's of course interesting is where and how do you deploy this stuff? So we as a company, we offer lifecycle management. We have a Lifecycle Manager product. We have an API gateway, which does security and orchestration, all of those kinds of things. And then we have Community Manager, which is the developer portal. And you can leverage these components either on-premise or in the cloud. We have a PCI compliant SaaS offering that you can leverage. But what most of our customers do, especially enterprise customers, is they kind of mix and match the models a little bit. If you're doing orchestration, it doesn't always make sense that it's all in the cloud. Sometimes because of the speed of light and the chattiness, it makes sense to do orchestration on-premise. So you might deploy some of our components on-premise and some of our components in the cloud. Or you might deploy some of our components both on-premise and in the cloud. It all depends on your use case and your costs and your CapEx structure and whether or not you want to do orchestration, whether you want to just manage onboarding, whether it's a private API, internal only, or whether it's public, whether it's for B2B partners or just for internal use. Primarily for the data center use case, it's deployed on-premise, simply because the SDN, the clouds, etc., are on-premise. But that is changing. People are using our orchestration capabilities and things like that in the cloud as well, unsurprisingly, because the cloud vendors are also in the cloud. So it all depends on where your control layers are for SDN. Where are your applications being built and deployed? What cloud vendors are you using as to whether or not it makes sense to go on-prem or in the cloud? I foresee for very large organizations that basically run internal cloud and are big enough to run internal cloud, they will deploy on-premise. For small organizations that are leveraging external cloud, deploying their apps into external cloud, want to orchestrate and manipulate external cloud and just want to abstract themselves from vendor implementations, they're going to use our cloud-based offering. But it's available in both formats. The cloud-based version is PCI compliant, and you can always contact us for more information. So, in conclusion, Datacenter API lets developers and administrators tap into the data resources through the APIs. It creates an API-driven, software-defined data center. It builds infrastructure flexibility that avoids vendor lock-in, and it enables cloud-native applications. And that's the end of the show. Thank you very much for listening. My name is Alistair Parkinson, and I'm available if you have any questions, or we can do it out of band. Back to you, Hugh.
Hi, I've unmuted everybody so we can have an open discussion, but I'm also going to read a couple of questions that we've gotten over chat. And please feel free to send more questions in. As I mentioned earlier, if you can't, if we don't get to your question, we're sorry. We'll try to get to everybody. We'll answer you probably by email. So one question is, does this solution work with data center management platforms such as OpenView or Unicenter and so forth?
Yeah, it does. Now, those are typically either source systems or target systems, depending on what you're trying to do. In many cases, if you're just looking at alerts and alert management and things like that, then those are target systems. So events that are published out of the thing or configurations or whatnot that you're doing, we would integrate with those and either publish alerts based on SLAs and capacities or make them part of a back-end orchestration. Because in many cases, you're deploying you're deploying a new virtual machine, and you need to inform one of those back-end systems that this new virtual machine has been deployed and what the endpoints are. So there's a certain amount of orchestration that happens there as a source system. But then there's also the publication of events and alerts and things like that into those systems as pure management plays. So it's both on the back and the front end that we integrate with those kinds of systems, and it depends very much on what the customer has on-prem. But the ones that you mentioned are very typical and very commonplace.
Terrific. Can you give some examples of gaps or white space in some of the APIs that are available from various service providers?
Not specifically, without throwing anybody out of the bus, but under the bus. But everyone. There's a disconnect between APIs from one vendor and another, and the Venn diagrams, they don't overlap very cleanly. So, you might find that some things work on one vendor and not on another, and you might have to fill up a gap with some custom code, and that is worse, far, far, far worse in the SDN space than it is in the cloud space. The cloud space is pretty mature, and you look at the vendors and there's a lot of stuff that they have in common, especially the further you get down the stack. The higher you get up to topology management and app management, then you start getting a little bit of white space. But if you go down to like VM management and things that are a little lower level, there's a lot of stuff in common. But SDN, it's a bit of a circus right now with just how sparse some of the offerings are and the limitations. And then with SDN, you're dealing with both the front end, the northbound and the southbound, and the abilities of the network equipment. It's a challenge right now. So my suggestion to all of our customers is focus on really what you want to achieve, and you might have to roll out some infrastructure to get it done. You might have to have a greenfield kind of environment to get it done. And definitely focus on a couple of things that are going to give you a win in the short term, and make that part of your API. But it's very immature. Storage is better. There's quite a few storage APIs out there. It's fairly well understood. That's not so bad. Security is pretty good. It's pretty well understood. OAuth, OpenID Connect. That's pretty robust. We've got SCIM now for identity management. And it's pretty mature. It's just a matter of choosing, I guess, which standards you want on the north-facing side of things. But there are going to be gaps. So focus on what you want from a data center API, and then go down from there and fill up the holes that you need, or choose your vendors based on the holes that you have, and go from there.
Great. Okay. Question says, can you give me an example of how a telco will monetize these APIs if they plan to open it?
I think it's quite complex for a telco to monetize the stuff. I don't think it's improbable, but I think they're going to monetize at the resource usage. So they're going to, based on analytics, they're going to see, and based on quality of services and whatnot, they're going to see who's using what and build based on that. And we see that all the time. Directly monetizing a data center API is it's possible, and you would do that in our product by creating licenses. We literally have a thing called licenses, and associated with those licenses, you would create license terms, and associated with the license terms, you would associate quality of service policies. And that then allows you to divide up your data center API and create policies against it and allow people to subscribe to those licenses. And you would do things like, on the storage side, you would do it based on geography and storage capacity. On the data center side of things, you might do it by CPU and by memory. And for the other APIs, maybe you'll base it on the number of API calls, or just as a general capability. So I think that it's going to change based on what parts of the API the applications are leveraging, whether or not they want storage, whether they want cloud, whether they want to affect and control the network. And again, I think the network is the biggest challenge here in terms of monetization, is how and what and where do you provide control, and how do you monetize that. So there's a difference between monetizing the API calls themselves and monetizing it somehow on the back end or within some back end application. And I think both are at play here. You just have to figure out how you want to do it.
Okay, so there was another monetization question. It says, when using internal APIs, how would you monetize or get ROI on the API from a specific business unit?
Well, that's where all of the reporting and analytics comes in, right? So you're going to, as a business unit or as a platform manager, you're going to see what business unit is executing what applications and what APIs they are fundamentally using. Then you need to internally figure out what is the return on investment for using the API rather than building it themselves. And that should be an easy calculation, right? Using the cloud is X cheaper than building it yourself, and so on and so forth. Using our storage is Y cheaper than going out and buying hard drives. And based on that dependency, that dependency map that I showed you first of all, or earlier on in the slides, you can see exactly what apps belong to what line of business and what APIs they are using and how much of those APIs they are using. And it's very, very easy then to actually derive a report, because you have that set of analytics. You know what they are using. you know, therefore, hopefully how much they're saving, and therefore you can you can provide a return on investment report for that line of business.
Terrific. Okay, here's a question. What kind of support or operational models exist for Datacenter APIs?
Sorry, Hugh, can you repeat that?
Yes, I don't actually understand it myself, but it's what kind of support or operational models exist for Datacenter APIs?
I can take a stab at answering that question. Basically, let me just say, the person who's normally setting up a data center API is the operations manager or some IT architect within the organization. You know, they're trying to abstract their operational decisions that they make from a day-to-day basis about which cloud provider, which storage vendor, etc. to use. They're trying to abstract that from the apps that are being built. They're trying to separate their command and control layer from their underlying implementation layer. So it's being built and it's being deployed and it's being managed by that IT exec or that data center product manager, which is kind of an interesting role that we could discuss. But and the operational model is around building the data center API, managing the lifecycle of the data center API, integrating that data center API with the backend systems, negotiating with different vendors on the back end, managing the lifecycle of the apps as they onboard, managing and installing and running software like ours that provides you with the gateway capabilities, the orchestration capabilities, managing and operating the developer community. In other words, providing support and answering questions and writing docs and all of those kinds of things. So operationally, the day-to-day tasks are all around building and maintaining and versioning the API, onboarding applications and managing the workflow and lifecycle, and managing the developers inside the community.
Okay.
And keeping the lights on. Yeah. At the end of the day, you're running a service for your business. You're probably going to have 5 nines availability. It's going to require an infrastructure and a team to do so.
Okay. Another question. Should we go for SOA implementation in the organization and then develop APIs, or can we implement APIs and then later at some point implement an SOA in the organization?
Sorry, can you repeat that again, Hugh?
Should we go for SOA implementation first and then develop APIs, or can we implement APIs and then later implement an SOA?
So there's a couple of things here. I mean, one, you really want to build APIs from the top down or from the outside in. To coin a phrase. And you want to build your API potentially independently of whatever backend systems you might have. And that's going to require some orchestration and definitely some rapid prototyping. So I like our scripting capabilities because you can go in and you can rapidly prototype an API, and you can host it in the container with some pre-canned request responses, and you can get that API looking the way you want it to look and maybe even build some test applications against that. The problem with anybody building a data center API, a platform API, or any API inside the organization is the product manager responsible for the API does not run the development life cycles of all the backend systems that they depend on. So they're going to be putting demands on those backend systems, or just having to consume, mediate, transform, orchestrate the services that those backend systems already have. So, you know, to answer your question, you build from the top down, and then you integrate with whatever backend services there are. That gives you your API, your right granularity, your right definition. It's built as a product. It's done appropriately, and you also decoupled then from all the backend systems that are exposing heaven only knows what. I mean, we see SOAP over JMS, space delimited stuff over MQ. We see all kinds of things on the back end exposed by lots of different lines of business and development teams. But the idea is you want to get your API out there, and you want to get it as clean and as nice and as neat as possible.
Okay. On the external side, what is the best way to promote your APIs to developers? What methods would you use, and how would you ask for feedback on the API?
Well, it has to look like a storefront. You know, your API, you're going to go out there. Developers have a certain expectation of the API, the documentation around that API. The docs have to be super clean. The user interface has to be modern and usable. And I'm talking about the developer portal. And the user interface has to support collaboration. So it has to have discussion groups. It has to have chats. It has to have maybe even ratings and reviews. It has to allow the developers to see each other. They need to be able to see you. They need to be able to reach out and communicate. You need to be ready to support them with whatever technical help they might need. Even if it's internal, you need to think about, what would this look like if I was launching it on the internet and allowing people to use it there. It has to have the right business messaging, the right branding, the right everything. It can't look amateurish or half-baked. It needs to be well-supported, well-documented, well-managed. It needs to give visibility. It needs to have the appropriate availability, all of those kinds of things.
Great. One person has said, great presentation, so I just wanted to share that with you, Alistair. What tools are available that can perform orchestration?
Well, orchestration is a lot of tools that can do it, right? And you can do it in different ways. I mean, you can think of scripting as orchestration if you push the envelope. But so for orchestration, of course, you can use things like service buses, process servers, traditional, enterprise application platforms, all of these kinds of things. But what we found is that these are very heavyweight. And when it comes to APIs, you're really focusing on stateless synchronous kinds of services and API calls over HTTP. And as an API product manager within an organization, you need to really be able to orchestrate and communicate across a lot of different backend standards like SOAP and JMS and XML. And you need to be able to orchestrate those calls to expose maybe a REST JSON API over HTTP. So when we look at orchestration, we kind of divide it into two layers. The first layer sits within line of business, and everyone has an orchestration platform already, especially in large organizations anyway. And they're doing orchestration on everything from BizTalk to WebSphere to Oracle, and they're very happy with that. But the API developer, they need something that will take that and create their API. So we need to do orchestration at this level as well. It does not typically include business logic, or at least not a lot of it. That's typically in the backend systems. It doesn't connect natively to backend systems necessarily. It's typically composing a set of backend services or APIs that already exist, making them simpler, enriching them, transforming them, things like that. That's not to say you can't use our orchestration engine to encapsulate business logic as well, but you need to make the trade-off between this lightweight orchestration capability and things that you need where you need to preserve transactionality across multiple systems with two-phase commit and all sorts of things like that. That needs to be probably isolated into your back-end lines of business, and they need to expose standards or close to standards-based APIs or services that you can then use and orchestrate to create new APIs. That keeps you agile without being beholden to the back-end SDLC process.
Okay, so one final question. What is your process to create an API that meets specific internal or external needs? How do you develop a needs analysis to actually develop the API?
Well, that's a business analyst question. I mean, you need to look at it as a product. I don't have time. We could take it offline, but I'm running out of time. But you need to look at the top down as to what your API needs to expose to meet the actual business needs and how to enable your app developers to get done what they need to be done. Either they want to make money, or they want to save money, or they want to be faster, or they want to. So they have a lot of different needs, and your API really needs to provide that as opposed to hinder that. And that's kind of the core of top-down or outside-in API development. And it needs to be RESTful, it needs to be navigable, HETIAS, whatever you really subscribe to, and it needs to provide the technology sets that the client is expecting. And then you need to then turn around and figure out how you're going to actually provide that by integrating with a bunch of different backend systems. But there is a methodology. We have an ebook on designing good APIs that you're welcome to take a look and download.
That's a great segue I'm going to invite everybody to visit the SOA Software Resource Center on our website, soa.com. It's got a lot of interesting white papers and recorded webinars and so forth.